harder integration of fractions resulting in logarithms. So before we get started looking at some harder examples, let's just have a quick recap that if we have the integral of 1 over x dx, this is just going to equal to the natural log of x plus a constant. But in fact, this is probably not 100% accurate, and you actually want it to equal the natural log of the absolute value of x plus a constant. And here we're going to have a look at why that's the case. So if we have y equals the natural log of x, we know if you derive this, dy dx, we're just going to get 1 on x. What happens if we have y equals ln of minus x? Can we have this? Because we know we can't have the log of a negative number, but we can have the log of a negative variable, because as long as x is less than 0, this will hold true, because, for example, if x is minus 1, we'll have the natural log of minus 1, so we'll just get the log of 1, which is going to be 0, so that's perfectly fine. And if we have this situation, let's let minus x equal to u. So we're going to have y equals the natural log of u, and to find the derivative with respect to x, we're going to use the chain rule, knowing that this will be equal to dy du multiplied du dx, because the du's would cancel and we'd end up with dy dx. So if we let minus x equal to u, that just means that u equals minus x. We can find the derivative, du dx, which is just minus 1. So we know the du dx term is minus 1. Now we just need dy du. We can find that over here, dy du. Well, the derivative of natural log of u with respect to u is just 1 over u. And now dy dx is just going to be dy du, which is 1 over u, times du dx, which is minus 1. And u, remember, was equal to minus x. So we have 1 over minus x times minus 1, which is 1 over x. So if we had the function log of negative x, the derivative ended up being 1 over x as well. So what this means is that if we have the integral of 1 over x dx, we actually don't know if it was equal to ln of x or the ln of minus x, because it equals the ln of x as long as x is greater than 0. Sorry, this should be a minus x. And then if it's minus x, it's when x is less than 0. And this is the definition of an absolute value. This is our definition. So what we say is the integral of 1 on x dx is equal to the natural log of the absolute value of x, to compensate for this negative scenario where it also equals 1 over x. All right, now we're ready to jump into some examples. First example, let's look at the integral of tan x dx. We know that the integral of sec squared x is tan x, but what's the integral of tan x? And to do this, all we need to do is change tan x using our trig identities. And we're going to change it into sin x over cos x. Whenever we're dealing with fractions, we always should consider is the derivative of the denominator in the numerator. In this case, it almost is, because the derivative of cos x is minus sin x, but we just have sin x. But what we can do is we can throw in a negative in here and 1 on the outside, so they cancel out and not change the question, so we're just multiplying by a factor of 1. And now the derivative of the denominator is in the numerator, so we can say we get minus the natural log of the absolute value of the denominator, which is cos x, plus a constant. So that's the integral of tan x. Let's have a look at the integral of x over x minus 1 dx. So it looks pretty straightforward, but we have a bit of a problem because the derivative of x minus 1 is just 1, but we have x in the numerator and it's at the same power as the denominator, which is going to make things a little bit tricky for us. So one trick is that we need to make the numerator look like the denominator. So in order to make the numerator look like the denominator, we know we have x minus 1 in the denominator, so if we throw a minus 1 up there, to cancel it out, all we need to do is add 1 as well. So here we're just adding 0 onto the numerator, but we're trying to make it look like that denominator. And the reason for doing this is what we can do now is break this fraction up. So we can take parts of our numerator and put it all over our denominator and take the rest of the numerator and put it over the denominator. So we're going to be strategic and picking the x minus 1 over x minus 1 plus the extra 1 that we added over x minus 1. So this will still hold true because they have the same denominator. We just add the numerators and it gets us back to this, and the minus 1 plus 1 will be 0. So we haven't changed anything here. Integrating all this with respect to x. Now, x minus 1 over x minus 1 is 1 plus 1 over x minus 1. And this is a lot more doable now because the integral of 1 with respect to x is just x plus the integral of 1 over x minus 1. Well, the derivative of the denominator is in the numerator. So that's just going to be equal to the natural log of the absolute value of the denominator, which is x minus 1 plus our constant. Let's look at another example, one more. So we have the integral of x squared over x minus 1 dx. So very similar to the one we just did, but the x is squared this time, and it's actually a bigger power than the denominator. And if you have this scenario, something you want to consider is actually doing a bit of long division. So we'll be able to rewrite that term. So what we have is we have x squared divided by x minus 1. So we'll just add in our extra terms here. So we've got plus 0x plus 0. And now we do the long division. So x going into x squared x times, multiplying it out, gives us x squared minus x. Doing the subtraction, 0x minus minus x gives us x. And dropping it down, x goes into x one time. Multiplying it out gives us x minus 1, and 0 minus minus 1 gives us 1 for our remainder. Now, the point of doing that is that now we can rewrite, we can come to the conclusion that x squared over x minus 1, that was our division, because we were taking x squared, dividing it by x minus 1, that resulted in an answer of x plus 1. So we write that. Plus a remainder of 1, but you always have to take your remainder and divide it by the divisor, which was x minus 1. So this part out here. And if you combine this all together, you would get this. But this is a lot easier now to integrate than this term here. So we're just going to make that substitution. So this will result in the integral of x plus 1 over x minus 1 dx. And we just have to integrate these terms separately now. So the integral of x squared, is a half x squared. Integral of 1 is just x. And this fraction here, we have the derivative of the denominator is in the numerator. So we're just going to get plus the natural log of the absolute value of our denominator plus our constant for that final answer.